Welcome to another edition of Focused on Physics. In this video, we will review the three basic trigonometric functions. We'll start by reviewing the definition of an angle, follow up with a quick review of the three basic trig functions, and end with a simple example. An angle in its simplest form is the space between two intersecting lines. We measure an angle by drawing a circle with a center at the intersection of the lines. The circle is then divided into 360 equal parts called degrees. The divisions here are in 5-degree increments, making a 25-degree angle. For scientific work, a more useful measure of an angle is the radian, defined as the ratio of the length of the circular arc S to the circle's radius r. The size of the circle isn't important because the ratio of arc length to radius is constant. Let's extend this concept to right triangles. We will use the Greek letter theta to represent the measure of an angle. In a right triangle, the longest side is called the hypotenuse, and the two shorter sides are called legs. The leg closest to theta is called the adjacent side, and the leg furthest from theta is the opposite side. Of course, these terms are relative to which angle we are concerned with. We now define our basic trigonometric functions. Sine is the ratio of the opposite leg to the hypotenuse. Cosine is the ratio of the adjacent leg to the hypotenuse, and tangent is the ratio of the opposite leg to the adjacent leg. A simple mnemonic to help remember these definitions is SOHCAHTOA, where S, C, and T are the first letters in the three trig functions. O is the opposite leg, A is the adjacent leg, and H is the hypotenuse. It may be useful to write this expression down in the margins on your homework or exams. Now, let's look at a quick example. A baseball is thrown 20 meters per second at 33 degrees above the horizontal. Calculate the horizontal and vertical components of the ball's velocity. Before we begin, make sure your calculator is in degree mode. Here is a picture representing the problem. The ball's velocity vector, shown in yellow, is 33 degrees above the horizontal, shown in brown. The length of the vector represents the ball's speed of 20 meters per second. The velocity vector can be broken down into horizontal and vertical components with the aid of a right triangle. We call the horizontal component Vx and the vertical component Vy. Now, consider the cosine of theta. By definition, cosine theta is the ratio of the adjacent leg to the hypotenuse. Using our triangle, the adjacent leg is Vx and the hypotenuse is 20 meters per second. Theta is 33 degrees. Multiplying cosine 33 degrees by 20 meters per second, with the aid of a calculator, to solve for Vx gives 16.77 meters per second. The math for finding the vertical component is similar. We just use sine in place of cosine and the opposite leg in place of the adjacent leg. Using the triangle once more, we can multiply sine 33 degrees by 20 meters per second, again with a calculator, to get 10.89 meters per second. In this video, we covered angles and their measurements, defined the three basic trig functions, and ran through a quick example. Thanks for watching Focused on Physics. If you enjoyed this video, subscribe, hit that notification bell, and give this video a thumbs up. Leave me a comment to request new content for an upcoming video. Until next time, stay focused.